Hello friends, welcome back to our channel. So in today's session we'll discuss about one more concept in permutations and combinations. So in our previous session we have seen what is the difference between the permutations and the combinations, and also we have solved a few basic problems on permutations and combinations. So in today's session we'll see a few more problems on permutations. Let's start the session. So first let us see the formulas. So three possibilities where we can use the permutations, and then we'll solve a few examples. So the first one, number of permutations on n objects without repetition is NPN. So actually in our previous session we have seen that if you want to arrange the R objects from N objects, then we are saying it as a NPR. Okay, so arranging R objects from N objects, we are saying it as NPR, which is nothing but N factorial by N minus R factorial. So this is the thing we have discussed in our previous session, the introduction, the basic problems. But here the number of permutations on N objects. So from N objects we have to select N objects itself. So we have to arrange all the N objects. Okay, if you are having a question like arranging all the N objects, so those are without repetition, then it will be R is equal to N, right? So we will say NPN. So what is this NPN? So if you solve this one, so which will become N factorial by N minus N factorial, because R is equal to N. So which becomes N factorial by N minus 1, N minus N, 0 factorial, which is equal to 1. So which is nothing but N factorial. That means if you want to find the arrangements of N objects, those are without repetition, then it is NPN or N factorial. So that is the first formula, first and a basic formula. Okay, just remember. So we'll solve with different problems related to these things. Okay, and the second category. So if the number of permutations can be done while arranging N objects in circular order. See, here the question is, among N objects we are supposed to arrange N objects, but the constraint here is in a circular order. Okay, here we are not saying it as a circular order, so we are using it as a N factorial. But here, if the same kind of N objects we are supposed to arrange them in a circular order, then it is N minus 1 factorial. It is a N minus 1 factorial. N minus 1 factorial. So this is the second case. Remember this. And the third one, same. The number of permutations on N objects with repetition is, so with repetition means if there are N objects which are having some repetition, and how to arrange those objects with repetition means N factorial by A factorial into b factorial into c factorial into and so on. So where n is number of objects, n is the number of objects, a is same type of objects, same type of objects, a, b is also same, c is equal to same, d is equal to same. So like this, we need to find the number of unique things and number of occurrences of those objects, and we have to apply this formula n factorial by a factorial into b factorial into c factorial and so on, right? So just remember these three formulas, and now we are supposed to solve a few examples related to these problems. So n permutations without repetition, n permutations with repetition, n permutations arranging in a circular pattern. So let's see a few examples. So let us see these examples, so which we have seen just now, the formulas. The first one, how many different arrangements of letters can be done in the word Pascal? So here the word given is a Pascal. So first we have to check whether these letters in that word are distinct or equal, if any letters are equal. Okay, so yes, so let us stop this one because we are having two different letters, so we have to solve it. So I'll tell you such kind of problems afterwards. So let us take the same thing. Yeah. Okay. So how many different arrangements of letters can be done in the word bot? Okay. So don't worry about why we have why we have changed that word, because immediately we'll solve such kind of problems. Okay. So first let us see this one. So if here there is no repetitions, there is no repetitions. Whereas in the previous word we are having a repetition a, right? Yes. So here how many letters are there? N is equal to 1, 2, 3, 4, 5, 6. So all the 6 letters are distinct letters, means different letters. So if we want to arrange those distinct letters, that means without any repetition, what we have said, it is nothing but the solution. The solution is 6p6, which is nothing but 6 factorial, because all the characters, all the letters of this word are unique. There is no repetition, so that's why we are using 6 factorial. The same thing, how many 3-letter words, all those are distinct, can be formed from the word bond, the same word. So now we are supposed to find the 3-letter word. So n is 6, that means total 6 characters are there, 6 letters are there. Among that 6 letters we have to select 3 characters. Okay, we have to select the 3 characters. So r is equal to 3. See, 1, 2, 3, 4, 5, 6, total 6, and we need to form a 3-letter words, that means r is equal to 3. So then the solution will be, what is that? 6pr, that means 3. So which is 6 factorial by 6 minus 3 factorial. So which is 6 factorial by 3 factorial. So which is nothing but 6 into 5 into 4. So which is 120 arrangements we can do. So we can do 123 letter words from this particular 6 letters. All are unique, all are distinct. Okay. Similarly, next, how many ways the 3 persons can sit around the round table? So circular permutation. This is also called as a circular permutation. So in such kind of things, so we know that 3 persons means 3 persons are different. So there will be no repetitions, right? So obviously then it will be n is equal to 3, and the solution will be n minus 1 factorial. So which is 3 minus 1 factorial. So it is a 2 factorial. So only 2 ways the 3 persons can be arranged in the round table, and the 3 persons can sit around the round table. And similarly here, See how many ways that 10 boys and 10 girls can sit around the round table. So here also all are unique. There is no repetition, right? So here n is equal to, there are how many persons? 10 boys and 10 girls. So it will be 10 plus 10, which is equal to 20. So what is the solution here? If it is a circular permutation, if it is a circular permutation without repetition, then it will be n minus 1 factorial, which is nothing but 20 minus 1 factorial, which is a 19 factorial. So I'm not solving this 19 factorial. So 19 factorial ways the 10 boys and 10 girls can be seated around the round table. So these are the two possible solutions. I mean two different solutions. So which we have studied. Now we'll see the third category, that means how can we solve when there is a repetition. Okay, so first one, so taking a Pascal as an example, how can we do the number of arrangements? Okay, so that we'll see, right? Let us solve those kind of problems right now. Now see, same question, how many different arrangements of letters can be done in the word Pascal? So first we have to see whether the characters are distinct or any equal characters. So here there is a repetition. A is repeated twice, 2 times. So whatever the formula which we have seen first, that is NPN, is not suitable for this particular problem. The solution is not suitable for this problem. So we have to go with the third case or third case, that is permutations with repetitions. So we need to arrange the letters which are repeated, right? Now what we have to do? So we have to find out the n value. What is the n value? 1, 2, 3, 4, 5, 6. So total 6 characters are there. Okay. So n value is 6. Now we need to find out the unique characters and their occurrences. So let us take A means number of letter P. How many number of P's? 1. Next B, which is number of A's, character A's. How many characters? 2 characters. Next C, yes. So number of alphabets yes. How many? 1. And D, C. Number of letter C's. How many? 1. And A already we have done. And E, which is L. So number of L's is equal to 1. Now we are having 5 distinct letters with 1 repetition A. Okay, so n is equal to 6. So make sure that, so A, the number of A's plus B plus C plus D plus E should be equal to n. You can see 1 plus 2 is 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6. So 6 we got, right? So this A plus B plus C plus D plus E should be n. So we are having like this. Now what is the formula here? So n factorial divided by A factorial into B factorial into C factorial into D factorial into E factorial. That means whatever the characters we are having, everything we have to write, right? So solve 6 factorial divided by, what is the A? It is 1. So 1 factorial into, what is B? 2. So 2 factorial into, what is C? 1. 1 factorial into D, 1 factorial into E, 1 factorial. So if there are different numbers, we have to take that particular number, right? So what happens? It will be 6 factorial by all ones, so it will be 2 factorial. Okay, so this can be written as 6 into 5 into 4 into 3 into 2 factorial by 2 factorial. So you can solve it. Okay, right? So 3 4 12 and 12 5 60, 66, 360. So there are 360 possible ways we can arrange the letters of the word Pascal. That means with repetition. So this will be the result. So such kind of problems, that means if there are any repetitions, then we have to go with this particular formula. Okay, so one more example we'll see. Now let us solve this example, one more example in such a way. So here also we need to find the number of permutations of the letters in the word engineering. So first we have to check whether there is a repetition or not. So yes, we are having a repetition here, right? Now, so what we have to do, we have to find out the data. So what's the n value here? So count their characters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is equal to 11. Okay, and a, so which is number of e's. So number of e's 1, 2, 3. So 3 e's. And b, which is number of n's. So 1, 2, 3. 3 n's. And c, number of g's, capital G's. 1, 2. It is 2. And d, number of i's. How many? 1, 2. E, which is number of r, is 1. Okay, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. So you can add these things: a plus b plus c plus d plus e. So 3 plus 3, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 1, 11. Yes. Now, what is the formula here? N factorial divided by a factorial into b factorial into c factorial into d factorial into e factorial. So this is the formula, because we are having 1, 2, 3, 4, 5 distinct characters with repetitions. So that can be written as, I'll write here, 11 factorial divided by 3 factorial into 3 factorial into 2 factorial into 2 factorial into 1 factorial. So you can solve these things. Okay, you can solve. So 11 into 10 into 9 into 8, 7, 6, 5, 4, 3 factorial divided by, what's the 3 factorial into, what's the 3 factorial? 3 to 6 into 2 factorial means 2 into, again 2 factorial is 2 into 1. So you can strike off these 3 factorials and you can strike off 2 to 4 factorial and 6 and here, and the result will be 11 into 10 into 9 into 8 into 7 into 5. So this will be the result. I am not doing any multiplication here, right? So you can use a calculator and do the multiplication, find out the answer. But the procedure is same. So first we have to check whether this word is having all the distinct characters, and if all the letters are the distinct, obviously you can go with the NPN. And if it is not distinct, that means if there is any repetitions, you have to follow this particular format. Hope you understood. And once again, one more problem we'll see and we'll stop. Okay. See one more example in such a way. So here there are 3 questions in the same problem. So first question is, you have to find the number of permutations of the letters in the word programming. So whatever the approach we followed, the same approach we have to find out. And the second question, how many of these permutations comes with all m's together? So now we have to find out the permutation such that all m's should be in a single position. I mean, comes together. That means in a consecutive places. And the third one, how many of them begins with a letter R? So how many permutations we will be getting if the words begins with R, right? So let us start with the first one. Number of permutations of the letters in the word programming, right? So same approach, the number of characters n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, here also we are getting total number of characters 11 with repetition. And A, so the number of P's, it is 1, and B, number of R's, 2, and C, number of O's are completed, O completed, it's 1, and D, G's, number of G's, so 1, 2, E, A's, number of A's, alphabets A's, so which is 1, and F, alphabet M, which are 2, and I, which is 1, only one occurrence here, and N, GH, which are N's, 1. So you can count here 1 plus 2, 3, 3 plus 1, 4, 4 plus 2, 6, 6 plus 1, 7, 7 plus 2, 9, 9 plus 1, 10, 10 plus 1, 11. So total we got 11. So how can we solve it? Same formula, n factorial by a factorial into b factorial into c factorial into d factorial into e, f, g, h. So the same thing, we will go with 11 factorial whole divided by, so 1 factorial, 2 factorial, 1 factorial, 2 factorial, 1 factorial, 2 factorial into 1 factorial into 1 factorial. So you can solve it. Okay, I'm not doing the solution. So use the calculator, you can solve it. So these many ways we can arrange the letters of the word programming. So here we are having a repetition, so we are using the same formula. That's the first solution. Okay, solution of first problem. Now we'll go with the second problem. How many of these permutations comes with all m's together? So all m's should be together, right? Now, in such case, see, second one. In such case, number of characters are 11. The question is, how many ways the permutations comes with all m's together? So all the m's should be together. So what we have to do? How many m's are there? 2. So here we will be considering them as a 1. So whatever the count it may be. So the word may have 2 m's or 3 m's or 4 m's, whatever it may be. So all should come together. So that's why we have to consider all m's as a 1. So for the second one, right? For the second one, all m's should be considered as 1. So irrespective of the count of m's. So similarly, we can go with the same formula, n factorial by a, b, c, d, e, f, and g, and h. So here you can check now. So 11 factorial by 1 factorial, 2 factorial, 1 factorial, 2 factorial, and all ones 1 factorial into 1 factorial into 1 factorial into 1 factorial. So previously what we have done is, so we are considering m as a 2 occurrences because we are having two alphabets, the same thing repeated twice. But here we are considering all the m's as 1 and applying the same formula. So there is no difference among that. Okay, so this is the second solution. These kind of problems can be solved in this way. Coming to the third solution. So what is the third one? What is the third one? How many of them begins with the letter R? So how many characters are there? Total 11 characters are there. So we need to find the number of permutations which begins with R. So fix the first character as R. So we have to arrange all the remaining 10 characters. So you can consider the total number of characters as 10. Total number of characters as 10, because already the character R, any combination, the first character should be R. So we are fixing that first character as R, and now we have to make the arrangements of remaining 10 characters. Among the 10, you can see R is only 1 because already first one we have fixed with R, and M there are 2. now you can use the same formula. So what we are doing, so 10 factorial divided by, so what we have to do, so 1 factorial into 1 factorial into 1 factorial into 2 factorial into 1 factorial into 2 factorial into 1 factorial into 1 factorial. So same formula we are using, we are not deviating the formula, we are using the same formula based upon the constraints. We are just making the difference, right? So in the second case, we are asked to find all m's together. So we have to consider the number of m's as a single character. And in the third case, how many of them begins with R? So the first character has been fixed and we have to make the arrangements of remaining 10 characters. So we are taking the total number of characters as 10 itself. And we are reducing the number of R as 1 because first character already fixed with 1. Right? Right? So hope you understood this one. And let us stop here. We have covered all the 3 possible cases. One is without repetition, arranging all the n objects, and another one is arrangement of all n objects with repetitions, and another one arrangement of n objects which are arranged in a circular order, that is a circular permutation. So try to solve these kind of problems many and many, so that you will be very good at solving these kind of permutations problems. So unless you solve many problems in these permutations, you will not get a confidence to solve any kind of problems. So try to do or try to solve as many as problems in the permutations. Right? Yes. So let's stop here and hope you enjoyed the session. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.